Great. I'm going to talk a little bit about our work on adaptive machine learning for data streams. So basically what we are doing is we are trying to make machine learning methods that are adaptive. So why this is important? Well, you know, now last year during the pandemic, all machine learning models or data changed, all machine learning models didn't work anymore. So there was a need to adapt these models or to rebuild from scratch or to adapt them. The problem is that for building models, we need data. So this is why that was interesting. So how we build models. So usually what we do is that we decide if we do that every week, every month, periodically, we train the models, and we need to decide how much data we need. We are going to use the data of the last month or the last week. So yeah, there is always these parameters that we need to check and decide what are the best. So the nice thing of this data stream approach is that we don't need to do that. So instead of waiting to have all the data and then build a model, what we are going to do is that we are going to be updating our model continuously, one example by one example. So that is going to allow us to be adaptive and to be really, really much more efficient. So this is why this data stream mining, IoT stream mining, the nice idea is that we're going to be very, very efficient because we don't store the data in memory or in a disk. So we process the data one by one. So we do only one pass over the data. So we are very, very efficient in terms of time and memory. And also at the same time, we are adaptive. So if something changes, we are adaptive and we are able to rebuild the components of the model so that we are consistent with the new data. So just to mention two recent works on ensembles for data streams. So there is this work on adaptive XGBoost for evolving data streams with Jacob Montiel, Rory Mitchell, Iva Frank, Bernard Faringat, Talal Abdesalem. So the idea is to, you know, XGBoost is a very popular method because it's really, really good and is winning the Kaggle competitions. So for non-complex data, it's really, really a good method. The problem is that it needs to have all the data in one place so to build. So the idea was to have one method based on XGBoost that was adaptive and was streaming. And another one that we are quite interested is on fairness classification. So in this case, this is also an ensemble for data streams. And the idea is how we can have a model that is not discriminative, that is not discriminating in terms of features as race, gender. So yeah, for that, we were building these decision trees using these additional information gain measures so that it takes into account the discrimination features. And yeah, just to finish, we work also on open source tools. So yeah, we are leading this MOA project. So MOA is a project that is specific for data streams. So it's not storing the data, it's only doing one pass over the data. It's in Java, is related to Weka. It's a project started at Waikato. We have this book that is open available of MIT Press, where we explain the machine learning for data streams methods and then how to apply that using MOA. And as you know now, Python is becoming very, very popular. So we have also this library that is called River. This is a tool specific for Python, so you can use it in notebooks. And yeah, it's really similar to MOA, but it's specific for Python and Jupyter notebooks. In terms of big data, we have also this project that is called APACHE SAMOA. The idea is how to scale. And then in this case, we have this project that is based in Java. And the idea is that we can run in these big data systems like Storm, Flink, so that we can really scale. And it's nice that SAMOA has a high-level API so that we can build our classification, clustering methods, frequent pattern mining methods on top of that, and then we can decide where to run it, if we want to run it in Flink, Storm, S4, Apex, GRPAM. And finally, as you know, in big data, also Spark is really, really popular. So yeah, we have also this project that is called StreamDM that is specific for Apache Spark. This is built in Scala, but again, it contains all of these methods for data stream mining. And the main difference is that as the other software, we're dealing with one instance by one instance. Spark streaming uses batches of data. So we need to do that using batches of data. And finally, yeah, I think adaptive machine learning right now is quite popular because of this, because we see that when things changes, we really need to be adaptive, and this is quite important right now. Thank you very much.